could only find a voice, she'd hear something new and thrilling. Would she but bestow a willing?
And greetings. Welcome to the Evidence Reasons Academy. This is going to be kind of somewhat atypical day. I'm going to be doing some home renovation, and part of learning is also, doing things outside of, I guess, formal training. I mean, construction work and renovation is part of, part of things to learn. I mean, if we didn't have these technologies and skills, we wouldn't have what we have now. So I open a lot with some of the music that I was raised up with. It filled the home. It's the music that filled the home, especially because of my mother's taste in music. She loved Broadway the old Broadway musicals, not the modern ones, which I detest. I mean, these are like 70, 80-year old Broadway musicals. And it was from I think, a better time in American culture in some respects. Some respects, not all. Um, so hearing that sort of music in the house sort of lifts my spirits. It reminds me of a different and also happy time in my life. I would say happier. It was still a happy time. So let's see. Um, Glory and honor to our Lord and Savior Jesus Christ. As I've been renovating my house, I mean, it feels very uh, exalted to study general relativity and all this high-powered math and Lorentz transformations, electromagnetic theory, little bit of quantum mechanics. But to do carpentry work, it's hard to get motivated. But as I was reflecting, I was listening to the book of Chronicles and even to passages in like the book of Exodus, Leviticus, Numbers, Deuteronomy. There's a construction, there is a lot of description of architectural work. And it turns out Jesus Christ, when he came to earth, he's the son of a carpenter, and presumably then he would be a carpenter himself. That's, the family business. And so, Jesus was God of the universe. He spoke into existence the stars and the planets, the galaxies, the galaxy clusters, the great, gigantic, galactic structures. I mean, the earth is just a speck compared to that. When he came to earth, he humbled himself to be a human being. And rather than speaking things into existence, he would use saws, hammers, nails, construction materials to build things. And he could have spoken it into existence. He chose not to. He humbled himself to be one of us. It says in Hebrews, we have a high priest who can identify, who can empathize with our struggles. And so that sort of ennobled me as I work on this house. I try not to call it my house. It's the Lord's house. I'm just the custodian and janitor to this home that he's given me the privilege of being a steward of. And that's how I look at it. It says, and I'll dwell in the house of the Lord forever. So wherever a Christian is, that is the house of the Lord. And where he lives, he can make it also an extension of the house of the Lord. And as I thought about Jesus being a carpenter, he said when he was the night of the Last Supper, he said, I go to prepare for you many mansions. And I just realized, so the Lord was describing all these architectural works in the Old Testament, all the details of building the Lord's house, the Lord's tabernacle, and then the Lord's house in excruciating detail. And it really reads like what a construction worker or architect and a handyman and carpenter would be involved in. And the house of the Lord had lots of beautification. And so then when I think about the New Testament, and Jesus says, I go to prepare many mansions for us. There's the carpenter at work. So when you read the Old Testament, you see the detail and the carefulness and the meticulousness of how things are put together, the craftsmanship. At first it just seems so boring, but now having to do construction work, a little taste of it myself, I realized this is a beautiful thing. This is expressing how careful God is to construct things. And you see that expressed in nature on just like another, words without description. And even, all the description in like Kings and Chronicles of how Solomon built the house, his own house. Jesus said about the lily of the valley, I tell you, not even Solomon in all his glory was arrayed as one of these. So um, it made me think, if Jesus is building for us mansions in heaven, the carefulness is even more careful than what we see in the book of Kings and Chronicles and in the first 5 books of the Old Testament describing the tabernacle. Uh, because we get a picture of it in the construction of the lily of the valley at the molecular level. It's just all the wealth and science. Just there's nothing to compare to that. So our mansions will be even more beautiful. We accept that by faith because of the evidence uh, given that the Bible is trustworthy. And at the very least, there's more evidence for Jesus than, say, believing. I would rather put my trust in the name of Jesus Christ than that of Charles Darwin or any of these atheists that have nothing to offer me. So, that being said, those are just kind of my reflections. So, reflecting on these things, I became a little more eager to do renovation work in my home. So, now I'm just going to get to it. Oops, sorry. Oh, by the way, greetings, Chelo Gonzalez, Schnoil, and Breath of God. Thanks all for visiting. Okay, I'm here now, and it's been a while since I've done one of these streams on construction work. And the first thing I'm going to do is try to do some electrical work. Now, could be kind of interesting because this is going to be a live show of how I try to do electrical work. And this is going to be, could be very embarrassing. So let me just try to set some things up. I need to reset the camera. Since I'm going to do electrical work, I'm going to have to shut off some circuit breakers. And now I have a 3-way light that I'm going to be changing, a light switch, and that should be interesting. I'm also going to put on some gloves just to be safe. And okay, so I'm going to move this ladder here. I like wearing eye protection. All sorts of things can happen with eye protection. So let me just move that. And I'm going to move another ladder. see if I can get some electrical power. Get some electrical power. Around the world I search for you. I carried on when hope was gone. It might have been in County Down. Oops. Or in New York, or gay Paris, or even London town. No more will I go all around the world, for I have found my world in you. Okay, so now it is true that I self-identify as an electrical engineer. One of my degrees is in electrical engineering, but there's so much they didn't teach me about the wiring of a house. So in electrical engineering, you study resistors, capacitors, inductors. You analyze signals flowing through these circuits that are made of power sources, resistors, capacitors, sometimes inductors, transformers. And to do this, you need all this math like Fourier analysis, Laplace transforms, Fourier transforms. It's just heavy math. But we really don't have a lot of stuff with, we have in the United States what we call electricians, and they figure out how to wire houses. They don't really teach that in college because, let's see, the Institute of Electrical and Electronic Engineers. So electronics is usually low power. So computers, cell phones, and all, et cetera, operate at low power. All the computational horsepower has to be done at low, is preferably done at low power because there's so many switches. I mean, there are a bazillion switches, and if you're operating switches at high power, it would be just ridiculous power consumption. It would be also slow because you want to miniaturize it so you have a little more, you have more speed, so the signal doesn't have to travel so far, et cetera, et cetera. But I actually don't know a lot of how stuff is wired in the house. Not to mention, in the process of installing this, you want to be very careful about shock hazards, the building codes, and also construction. It has to have aesthetic appeal. When I was studying electrical engineering, we didn't care about any of that. I mean, it'd be kind of a rite of passage to see how many circuits and parts you could burn out in the lab. That would not be very good in a construction context. Snoil says, my father is an electrical engineer. He seems to really love that stuff, Fourier transforms, etc. So, yes, electrical, your dad and I are on the same wavelength. So surprisingly, a formal degree in electrical engineering, you have so many specialties in there. You have some people that are so far removed from any circuits, they're just pure mathematicians. So they figure out then how to pump. I mean, a good example would be Claude Shannon. He figured out the theory of communications and Shannon's theorem, signal to noise ratios. So they figured out how many bits you could pump through a wire, and you have all these coding schemes, and then kind of the limits of physics of how you could construct the wires, and then the modems, etc. What are the theoretical limits and what you can possibly do. And then you leave it to another set of engineers to actually do all the hardware. So you have all the levels. Now the theoreticians are extremely important because if they can come up with a algorithm to improve the speed of communications and data reliability by 5%, you can beat your competitors. So we have electrical engineers that all their life they're just doing um, electrical engineering theory. Again, with Fourier transforms, they do stuff with modeling white Gaussian noise in the circuits, all sorts of incredible math. And then you have the more, people more closer to the hardware level. You have the chip designers, et cetera. And then you get then into the digital world, which is close to the computer world, et cetera, et cetera. What you don't get in formal academia as far as electrical engineering and electronics engineering is how to change a light switch. I'm not kidding. You're not going to get, if you look at the colleges in the United States, the electrical engineering program will not teach you how to change a light switch. That is another set of skills. And then all the terminology, there's a lot of different terminology that's a little bit unnerving. Let me check something first. Okay, I was just, I hope you can hear me. I was doing kind of a mini sound check. So there's a lot that is just, there's so many specialties because learning how to change a light switch won't help you solve really difficult communication problems like trying to build, because electrical engineers in the modern day and for a long time, is building communication systems. So like telephones, radios, walkie-talkies, etc. In the Defense Department, that is a huge deal. And what they call controlling the electromagnetic spectrum. And this whole thing about radars and then stealth. And there was other things, spread spectrum communications and electronic warfare, electronic countermeasures, electronic countermeasures. There's this whole realm of electrical engineering that deals with that stuff, and billions of dollars are spent on this. So I was amazed that when they built an airplane, like say a fighter jet, that maybe 20% is all the actual flying stuff, the physical stuff that makes the airplane just physically fly, like the wings, the fuselage, the cockpit, etc. But then the other 80% were all these black boxes, what they call effing black magic, FBM in Air Force. All these boxes, all these gears, all these gizmos, these radars, these communication sets, these just all sorts of these interfaces, what they call avionics. It's just incredible. So a lot of expenses in defense equipment in the modern day is for the electronics and that's where the high tech is. So for example, I mean, you can launch a missile because of all this high tech stuff. You could launch a missile from thousands of miles away and it'll be precise down to the meter. That's because of the electrical engineering involved. But then learning how to do this is a new skill for me. So the first thing you'll note is that there's some plaster here. So when they were hammering on the drywall to install this box, I guess it's called a box where you put the light switch in, they ended up dinging the drywall, and I just had to repair it because even when we got the house, there was still a hole up here. It's not very noticeable, but it got on my nerves. So I put some drywall tape, and then I put some of this plaster here, and then I sanded it down. So now, I really shouldn't leave the switch hanging out here, but let me just see. I could flick the switch. Look at that. And so the camera is on the smartphone that you're seeing me on is able to automatically adjust to the light levels, and that's why you kind of see this. It takes about a second for it to do a readjustment. like that. Look at that, how cute. See, this is natural light because it's Saturday, 12:42 p.m. Eastern Standard Time, and there's lots of natural light coming in through the windows. That I like that light better than this artificial light. So, and Schnoll says, it's the same for me, Sal. People tend to think I know how to repair their printer since I study computer science. Haha, I don't. Yes. So you're going to see me struggle through learning how to change a light switch. Now, some of them are relatively simple, but this is a three-way light switch, what they call a single pole double throw light switch. There's 4 wires that go into it. You're like, well, a light switch, you just have, something where the negative and positive and the electricity flows. There's only going to be 2 wires. That's correct if it's only a one-way light switch. So a three-way light switch is when you want to be able to control a light by 2 different switches separated by distance. So it's sometimes convenient, like let's say you're in a stairwell, you want to turn on the light by just flicking a switch one place, and then when you're downstairs, you can flick it off. You don't have to go up, run up and down. So 3-way light switch is more complex. And I actually had to study the diagram for about 45 minutes. And it's like, yeah, I sort of know. And there's 3 kinds of light switches, light switch ways that historically have been used. They call it the traveler system, the California system, and the Carter system. I'm told the Carter system is not allowed in the United States for 3-way switches. There is the California system, and then I think this is the traveler system. I don't have the specifications on the traveler system. I mean, whether this is indeed a traveler system. So I'm going to just guess here how to wire this. I looked at the YouTube videos. Oh, greetings, Ben Rex. So I was just opining about electrical engineering and how they don't teach you at least in the United States, in the electrical engineering community, how to replace a light switch. I guess, they focus on things like building radars and communication systems, lots of math, kind of the more everyday household stuff we don't learn. There's different terminologies. They have something called like common and hot wires. I don't know that there was ever in any of my electrical engineering books that they talked about the hot wire, or I don't even remember. And then you have this 2-phase, 3-phase power. There are all these things that, I mean, there was maybe 2 classes that covered the 3-phase power, and then how you can convert, like here in the United States, you can convert like 110 to 220, or wait, I'm sorry, 210 to 120, depending on how you wire it. There's a little bit of stuff with step up, step down transformers, but that was just one class. Whereas the electricians, they know this. There's also different color coding. So in the United States, you have the black and white wire. And when I do electronics in the lab, you have black and red, or red and green. And maybe every laboratory might have their convention of what's positive and negative. And then they don't even use those terms here because it's AC power. But there is polarization, and there are all sorts of electrical codes. So, and there are conventions of how to put wires through the house, and their building codes. So that's what an electrician would study. So this is probably a violation of some sort of safety thing, where I have this 3-way switch just hanging out here. Now I'm going to show how the 3-way switch works. If I go to another area in the house, I can control this light. So now it's in the off position. I could turn it on with another switch. So I'm going to turn it on with another switch. Hang on. And see, now it's on. See, but this is in the off position here. but I can control it with another switch while it's in the off position. But now when I turn it on, when this is in the off position, kind of in the down, I should call it the down position. I'm sorry. When it's in the down position and the other one is in the up position, now the light is on. But now I can, if I put this in the up position, now it is off. So now I've just kind of reversed the way it works. That's kind of a little hard to get used to. Because normally we think when it's up, the light is on. When it's down, the light is off. But in a three-way switch, the convention is it depends. It depends on what the other switch is doing. So now I'm just going to make this more normal here, just for my own sanity. I'm going to move the other switch, I think, in the up position or down. I'll see. Let's see. Okay, I had to move it into the other switch. I moved in the up position, and that turns the light off. So moving it in the up position turns the light off, the other switch. But then I call this the primary switch. It now looks normal that it's in the down position and the light is off. Now I'm going to switch this on. All right, so now I'm going to wear gloves just for a little extra level of safety. I'm going to run downstairs to the breaker box, and I think it's circuit breaker number 10. I literally spent 5 hours finding out what circuit breaker was connected to what outlet, what light switch, etc. And it took 5 hours it was trial and error. So now, let's see. So Ben Rex says, I didn't learn how to wire houses. I learned how to wire machines, different norms and different levels of complexity. Cool. Do you have apprenticeships in Germany? Okay, so now the way they wired our house here is they didn't do it like one circuit breaker per room. I guess the philosophy was you didn't want one circuit breaker to blow and it would just wipe out the entire room. So what ends up happening is one circuit breaker will control a set of outlets in 3 or 4 rooms, outlets and light switches, and then another would control another set. And so to wipe out the whole master bedroom, it would take 4 circuit breakers. So it added some redundancy, but then it also spread out kind of the effect to the other rooms. And I think overall that was kind of a good strategy so that you're not in the dark. You at least have, you could tell something went wrong, but you still have light. You're not going to be just groping in the dark. It was kind of nice. And that's the way where we are. Ben Rex asked, what voltage do you have there? We have, for the light switches and the outlets, it's 110. 110 at roughly 15 amperes is standard. It's a little more than that. So that'd be what, 1800, something about 1800 watts. But you can bump it up a little more, you can cheat. But the circuit breakers are rated at about 15 amperes, 110 volts, something like that. Sometimes it'll say 120. But that's a little bit deceptive because coming in, the electricity coming in is 220, 3-phase power. And so you kind of like have a reference 0 and you have a positive negative. So you can get like you can divide that into 110 without using a transformer. See, now again, this is the conventions here. This isn't really what they teach you in school. Because a lot of electrical engineering is done, a lot of electronics engineering is done at voltages less than 20 volts. You know, so for example, that's why the laptops are at about 24 volts at most, 18, something in that range. Our cell phones are charging at like say 5 volts. A lot of transistors are in that voltage range. So the voltage here is 110 for the outlets. The electrical outlets are 110, but there are appliances in the house like the dryer that operate at 220, and the heating and air conditioning, the heat pumps, I think operate at 220. So they use the full scale, and these are high power applications. I think some of the ovens and the stoves, the electric stoves, are still 110. I don't know that for a fact though. So in American houses, you have a mix of voltages for the high powered appliances, and then it's down to 110 for the low, but 110 can still kill you. 12 volts is nice. You can touch it, it won't kill you. I will say though, I had a short circuit over a battery, and those things can deliver 100 amperes. I was nearly blinded. I was seeing flashes, and metal was getting molten. Um, the wires just melted, even at 12 volts. But like 100 cranking amps was just flowing through there. So now for safety, I'm gonna before I disassemble this and reinstall, I'm gonna shut off circuit breaker 10, and I'm gonna run downstairs. I'll be right back. Okay, so it looks like this is now disabled. Good. One thing I learned in high school electronics is the high voltage, high being like, well, really not high, but typical household outlet voltages. If you touch it with the back of your hand, you might have a chance to pull away. Electricity will shut down your nerves. And what's really bad is if you happen to grab a wire and it's hot, your nerves may not work. You'd be lucky to be able to pull away. You might have, if you have enough energy in your legs, you might be able to push it. I mean, if the electricity is not affecting your legs, but it will affect your nervous system around your hands. And so that's dangerous. That's dangerous. So there are extra measures of safety. I know some electricians are very confident they don't wear gloves. They do have rubber boots, which is good to protect them from all sorts of shock hazards and things like ground faults. Again, I didn't study what ground faults are in electrical engineering. Now you're wondering why I'm changing this. It's for an aesthetic reason. We had a relative that lived here before. Ooh, there's a nail pop there. I have to remediate that. Ooh, I just noticed that. There's a nail pop here. There's a nail. Hang on. That's going to get on my nerves here. I just noticed that. So over time, because of heat and stuff, nails start to loosen up that had been used to fasten the drywall. The convention now is to use screws, which are not less likely to just spontaneously slip themselves out. And so there's a nail pop, the nail is starting to pop through the drywall here. The technique is to hammer at it, to hammer it back in, put a reinforcing nail nearby, and then plaster it over. That is to help secure the wall from falling off. And actually, you'd be kind of horrified if you saw just your walls are being suspended just by a few nails. One time I did add some drywall and a contractor was laughing. He said that you really used a lot of nails. I'm like, I wanted it to be secure. It's like, no, you don't need that many. But he told me about how walls, he worked on some sites, and when they started doing construction, some of the walls would just fall off. So there is this really neat tool. Hang on. There is this neat tool called a stud finder. It's called a stud finder, and it finds out, there's a lot of hollowness in the walls. There are these beams, these wooden beams that they also call studs. And I can find out if there is a wooden beam traveling through here, which I suspect there is because the outlet is right here. So what I do is I just press this, and when I slide it across, when I hear the beep, that means it's sensing a beam of wood. Yep, see, watch. I'll slide it. It senses the beam of wood. As I continue to slide it, it turns off. That means the beam of wood is roughly there. So that is a nail. And I found this, my friend and I were disassembling a computer, and I think like the disk drive or something has a really powerful neodymium iron boron magnet. And so I said, he just kind of gave it to me. It's like, what am I going to do with that? I have tons of magnets. So what I decided to do is I sawed all the extra extraneous stuff off, and I said, I've got something that can detect nails in the wall. So watch this. Let me see if I can find it. Hang on. So I have this magnet here, and let me see. So I have a magnet here that I got from a computer. And oh, hi, Mark O'Connell. And this is a drywall screw. And you could just see how this thing it's just incredible. So it's very strong magnet there. And there's a nail right here, I bet. Because I could just slide this, and you can see it falls. But once I move it up here, you're going to see it stick to the wall. Isn't that cool? So I confirmed that the bulge there is a nail pop. And now I'm going to remediate the nail pop. See, if I move this magnet down a little bit, it's going to fall. That's because it's metal right there. So I have two lines of evidence that I can confirm there is a wooden beam behind the wall here. First off, I have that magnet there saying that there's a nail there. That means there's wood behind it. See, this is what I'm trying to say. You can infer things without directly seeing what's there. This stud finder has, I guess it's like a sonar. It can sense, it's a depth, it's a material sensing sonar. So again, as I slide it across, you'll see it goes from green to red, and it's going to give me that tone. So that's where the beam starts, right here. And it ends about right there. So I'll slide from here. And you can see it there. Now what I'll do is I'm going to mark here. Maybe I'll even mark up here or down here. I'm going to drill to do a reinforcement of that wall. But the first thing I'm going to do is I'm going to hammer on that nail pop. You can't really see it on the camera, but there is a slight bulge here. I noticed it now. But it does indicate weakness in that the way the drywall is fastened there. It would be good to remediate it. It would be good to remediate it, because if you keep letting it go, eventually your walls could just fall off in an inopportune time. So it's just like changing oil in the car. You try to you neglect it long enough, and when the oil's gone, you could have catastrophe. So they say a ounce of prevention is better than 10 pounds of cure. Yes, a person needs two lines of evidence to find a nail in the wall. So here it is, the magnet, and I have a sonar stud finder. These are only like $10 or $20. A great device. So you can't see the nail behind the wall. So I'm just going to hammer. Of course, it damaged the drywall a little bit. I'm going to have to put some plaster on here. You can see where I've done some of this in other areas. I'll show you here. It's really clear here. So there were all these nail pops, especially along this beam. You can see it follows this beam here. And I reinforced, these nails were popping out. There were quite a number up in the ceiling. So I'll just show that a little longer. And so I already put plaster, I already pounded this in, put a reinforcing nail, plastered it, and then sanded it. And when I really hate that ugly blue color. That was my relative. He's gone now. I'm so happy. And I can make this white. So anyway, so it's hard to see on the camera that there's not an indentation down here. I'm going to mark the position where the wooden beam is. So if I drill in this area, there's no wooden beam. Behind here, I want to put the screw where the wooden beam is. So I'm going to use the stud finder. Now, what I'll say is I could just assume that this nail goes directly down, and that would be an okay way of determining it. Where to put, I'm going to drill a hole beneath where I made that, remediated the nail pop. The problem is I've noticed they sometimes missed where to drill the hole and to put the nail. I found one yesterday. That nail was just going to nowhere, and that's bad. And also sometimes it's not really centered on the beam. It's better to get the nail right in the center of the beam. Sometimes it's just at the edge. I prefer not to do that. So the way I actually learned this skill is with a liquid crystal display television screens, trying to mount them on the walls. You have to find out where the wooden beams are where you can drill. So let's look. I'm going to do this again. Okay, there and about there. So let's actually, the guy who inserted this nail was actually on the mark because it's pretty much dead center. So the standard technique is to hammer at the nail pop. Just leave the nail in there, don't remove it. I and a friend actually had sometimes removed the nail. I don't know that that was the best thing. It may pop out again, but if you put the reinforcement, you know, my feeling is if it popped out one time, it might pop out again, and you're going to have to go around hammering, which is going to be, I'm not sure that I want to do that. Yeah, what are we going to do if Sal gets an electric shock? Hey, you don't have to worry because I'll be in heaven, okay? So to live is Christ, to die is gain. So now I put on my goggles, and let me tell you, I know probably for drilling I don't need to put my goggles, but it's been a good habit. I think I would have injured my eye several times if I didn't have the habit of putting on goggles. Even walking, I don't have very good depth perception. I barely passed that in my pilot exam, medical. And I've walked through like kind of, you know, between the trees and all, and stuff would just smack me in the face, and you know, I'd hear this click right on my goggles. I'm just like, I didn't see that coming because I just don't have good depth perception. So I need to get I have my little Home Depot. Look at this. I have a Home Depot apron. In the apron, I have my drill bits and screws. And I have a drill bit here. It's about the right size. Now I actually have, so I'm going to drill here. Oh, the other thing is there are probably wires running along this beam. I don't want to be just drilling randomly. I could go right into a wire. So let's get this going here. How many theologians does it take to change the light bulb? Actually, I don't know. There must be a joke there. Okay, see, there's electricity in some of the outlets, and hopefully this is not hot. I do have to confess, I actually found out after the fact that I actually changed an entire outlet when it was hot, when there was electricity going through it. I switched off the wrong circuit breaker. Yes, I didn't follow safety procedures. I didn't have my multimeter. I had a light. I was careless. I could have easily checked just by, you know, inserting a lamp or something. And I was like, oh my goodness, I'm glad I took the extra measure wearing the gloves and everything. That outlet was hot when I was changing it. So, okay, so Now that was really hard wood. I could feel when I was drilling, the drywall just cuts through like the drill cuts through like butter, and then you feel that wood. And I can actually feel the different qualities of wood. I can sense it just by how easy it is to drill. The wood up toward the roof and the ceilings is really hard. I mean, I have to force. This is kind of moderate. I get very concerned if it feels like it's just butter, because either it means there's no wood there or it's rotted. I haven't had that situation where I think it was rotted. So now this is where I could embarrass myself. There's hard to find a drill bit that will actually, make kind of the right diameter for the screw. The other thing is these screws, you can see these self-tapping screws, they get thicker, the diameter increases toward the head of the screw, and it gets very hard to actually insert it in sometimes. It actually took me 5-10 minutes to insert a screw because the wood was so hard. I mean, it was really hard. The drill was smoking when I was drilling through. It was really cool. Pieces of the sawdust fell on my hand. It was hot. I mean, I had to jump. I mean, it was really cool to be drilling through wood and it's smoking because the wood was so hard. In this case, the wood was kind of soft. All right. So I don't think the wood is that hard here. I should have an easy time. We'll see. Okay. Yeah, and of course I dropped the screw. Okay, try again. That was easy. Okay, that didn't take it took less than 30 seconds. I was doing this on another wall. It took 5 minutes, to keep re-drilling and stuff. I was getting kind of concerned. It's like, am I doing something bad? Okay. Now, you see this switch has kind of a beige color, and I want it to be white because it's going to be the color. This is the thing, when you repaint a room, it looks so nice. Everything that's not the same color just stands out. So I want it to be the same color as you could see the rest of that room there. And so it's really for a silly reason that I'm changing this. It's purely aesthetic, because obviously it's functional as a switch. But hey, it's just an aesthetic change. And it gets in the back of your mind. Some of the ladies in the church were helping me decide on renovations. They'll notice stuff like that. And they'll say, "Oh, you need to change the light switch." I'm like, "Oh man." Anyway, so let me try to unscrew this. So the technique is just so you keep the accounting correct, is to just change one wire at a time. This is also a very interesting setup because they use what's known as quick wire, and I'll explain that in a little bit. Guys, this is embarrassing. I misplaced the part. Give me a moment. Let me see if I can find it. I misplaced the replacement part. It's somewhere in all this pile of stuff. Oh, praise the Lord. I found it. I found it. So you can see the difference in color between the two. Yeah, I know. It's purely aesthetic. So, um, so the wiring of a simple switch, you'll just have like, you put a wire here and a wire here, and that's it. Very easy. This one has 4. This has a grounding wire. I still don't understand what that's for. And I've actually seen some electricians on YouTube not attach the grounding wire. And so the nice thing is they color code the wires here. Now there's something interesting. They have what they call the quick wire set. It's kind of hard to see here. Let me see if I could, let me move some things out of the way here so that I could bring the camera really close. One moment. Get the hammer. It's actually, the camera here is pretty good. It's actually darker to my eyes than it looks. But I'm gonna show something here. I'm gonna switch the camera direction a little bit. Okay, so all right, so I could see this a little better now. They have what's called the quick wire set. And you could see it doesn't actually go into the screw. What I have to do is actually yank this thing out. Now, I don't have a good camera set up where I could actually show how I yank this thing out. Okay, so that's quick wire set. I'm going to just be trying to pry it off. And there's a little technique to that. For those interested, you could see how it's done on YouTube. That's actually a new skill that I wasn't aware of. Oops, I misset the camera. One moment. Settings, camera. Okay. So you're not going to actually see me unscrew the wire. I have to yank it out. And the way to do it, let me put my goggles on just for safety. Where did I put my goggles? There. It just feels safer when I work when I have these. I need to get a pair of pliers. I have to actually insert a, it's kind of dark in here. There's supposed to be a slot where I insert a screwdriver and I could pry this out, but I don't think this has a slot. Nope, I'm just gonna have to use a pair of pliers and yank this out. Let me get my pair of pliers. So they're supposed to be like, it's not exactly an alligator clip. There is something here that grabs it. And you just have to kind of just yank it out. Unless there is a, it's so dark here, I can't see. Let me see if I can get a flashlight on it. Obviously, if I were, you know, I'm kind of learning all this on the fly, so I'm very slow. Okay, let's take a look. All right, there is, looks like there is a location where I can insert my screwdriver. Let me get over here. Yeah, there is a location. I think I can, I have to use a smaller screwdriver. See if I could find it. Oh, what a pain. This is the thing about not knowing the tools you need until the last minute. I just need a small screwdriver. It won't fit in the hole. I had most of my tools in one box, but where did I put that real small screwdriver that can go into that hole? Ah. Well, I'm going to improvise here. Let's see if I could put a drill. No, a screwdriver would be best. So I have this teeny screwdriver here. I really wanted one more substantive, and right when you need the one of particular size, it's not there. I'm going to take one more look. Let me try it with this. Come on out. There, praise God. All right, I got it out. See, this is where, I tell people I'm not really versant with all the tools and stuff and all the techniques. That's why I'm not really fast at doing some of this. And now I have the switch. And so this is interesting. You see, the wire, it's supposed to be a dark color screw, but this is like a 40-year-old, this is like 40 years old. I know it's kind of hard to see. Bring that a little closer. You could see here that the screw has different colors, the light color and then the dark color. This one, the screws are the same color. Now they're color coding in wires, and they say what you have to do is make this wrap it around clockwise. So this is where someone has been doing this for a while is really good with managing the wires. See, I'm really slow at making the wires. I have to get this bent right. And someone who's done this a lot can, just has a lot of facility. I should sand this down. I could see a lot of, a little bit of corrosion there. I'm gonna sand it down. Just to improve the contact. I mean, this is like going the extra mile. I mean, it should work anyway without sanding it, but I'm just going to make the contact really clean. So I'm using some sandpaper. So, Lord, thank you. I mean, an electrician, a professional, would be able to have done what I've done in like 5-10 minutes. So, I mean, I kind of understand it conceptually, but to be able to have the facility, you know, and they have all the tools all arranged, you know, all the meters and stuff. They probably have specialized tools to curl the wire and the strip or whatever, strip the wires. So I have to kind of just do this manually. Okay, I think that rotates in the clockwise direction. Okay, I can mess this up because this is more of kind of like the art than the science of it. I mean, ideally, let's see. Okay, it's going to be like that. No, I wound that the wrong way. I'm going to wind the wire the other way. So this is the more obnoxious stuff. It's not the theoretical, it's just really kind of the craftsmanship side of home renovation. You know, I'm really slow at doing this, but oh well. You get what you pay for, right? You know, the pros can do this in a snap. It's just taking me forever to do a simple task. Okay. So that's actually a good way of wiring it where it's clockwise. So when I turn the screw, it's going to capture it. I mean, there might be reasons to complain about the way I did that. Let's see if I get another. I'll use the Phillips tip. I like the flathead screwdrivers better. Okay, that's good enough. Now I have to do the same thing here. We're going to use the pliers. Let's see. And see, I misplaced that. In the panic, I misplaced that small little screwdriver. So I'm going to undo the quick wire here. I actually don't know for sure if that's how it's secured, because I don't see a spring. It might be I have to just loosen this, and then this will pull. All right, let's just try to see if I can just yank. Lord help me. Okay, it's coming out, I think. I'm just pulling. I don't want to pull too hard because I don't want to rip the wires to pieces. Because I don't want to have to do a restrip. Okay. All right, I'm going to try to then. This is why I wish I had my tool. Yeah, there definitely is. When I insert this screw, there is a place here, when I applied pressure, it did loosen the wire. So there's a little hole in there. I push this and it releases the tension that's grabbing the wire. Okay. Okay, so now I loosen that up and I want to try to get this rotated into that screw. Okay. I think that's just about the right length of the insulation. There is actually a little trick here. There is like a wire guide somewhere right on the fixture itself. You can just, it'll tell you how long. Oh, here it is. There's a little notch here, and that's exactly how long it's designed. If you have it at least that long, it's good. It's just, it's maybe a quarter centimeter longer, which is fine than you need. So I have to wind this clockwise. Do this clockwise here. All this to change a light switch. Okay, because there are issues, you know, it's easy to wire stuff up in the breadboard laboratory, you burn stuff out, but anytime you have something permanent, you know, you want to have it a certain level of quality because it needs to be durable. And seem to have misplaced my screwdriver. Now, technically, this is a little long. It's exposing a little too much wire. This one's about right. The problem is you can't avoid having exposed wire at some point. It's never closed. You have these open screws inside the box. I guess that's within acceptable building codes within the United States. Now, something funny here. Okay, before I get there, some of this, I'm going to see if the screw actually can go in there. I've actually had problems. So now I'm going to try to loosen the other one. And I have my little screwdriver here. This is a trick. I have to be able to push down here. I'm going to put the screwdriver in here to trigger the release mechanism and then simultaneously pull. And this is funny because I'm right-handed. Okay, see if I could try to use the pliers as my left hand. This feels so weird. Oh, okay. See that release? See how easy it came out when I was able to squeeze down the release mechanism? So let me put away this my screwdriver. I'll remember that because I actually didn't know. For an electrical outlet, I knew where the release mechanism is, and every manufacturer puts the release mechanism maybe in a different spot. So that's quick wire. I could see why there's some benefits of this quick wire. All you do is you just strip the wire and then just plug it in and it's secure. You don't have to go through all this, you know, shaping the wire and then inserting it and putting it in the screw. I will say one of the drawbacks, and I didn't strip the wire, I didn't clean up the wire here earlier. One of the drawbacks with that technique is I've actually had an electrical fixture just kind of it started to loosen itself, and there were sparks and sounds, and a very uncomfortable sound. Now, that's not to say that with enough, you know, let's say you're using an electric space heater, I could imagine that it's going to cause, you know, over time that it'll unscrew itself. So I didn't strip this one down. I didn't sand it down. So there's all sorts of stuff that accumulated on this over time, and I'm just cleaning that out. I could have done that on the other one. Hopefully it'll be good enough. So, okay, I'm going to turn this here. I think that's going to be good enough. Where did I put the screwdriver? Here. See, a professional would also know, they would know how to arrange their tools so that they're not constantly groping and fishing around for where their tools are. I mean, they would know in advance. It'd be like clockwork. Right now, I'm just kind of learning it on the fly. I'm not sure that that's the best. Okay, I'm going to be a little mischievous here. I hope I don't. See, this is curiosity killed the cat. Okay. I haven't hooked the ground wire in yet. Want to see something dangerous? I think I'm going to try something dangerous here. I'm going to see if I can get this switch to work without the ground wire wired. Because I saw this on YouTube. I'm really curious. Okay. We'll see if this works. Be right back. I'm going to cut on the circuit breaker. Look, I partially wired this and the light's on, and I can operate the switch, and it's not even completely wired. So I still don't understand what the ground wire is for. It's a safety issue. Okay, but because, I'm trying to teach anything we do on YouTube, we want to be responsible and communicate good information and not teach unsafe practices. So I'm going to wire the ground wire. I'm going to have to shut off the circuit breaker again and wire the ground wire. So apparently this ground wire is for safety. And that's something we don't do in low power electronics. We don't really focus on that. I mean, 9-10 volts isn't going to kill you. So a lot of our circuitry didn't have these grounding issues, and I don't know what that is for. I really don't. They never teach that in academia that I know. So I can operate the switch even though I've installed only 3 of the 4 wires. Now let me just check to see if the I can control it with the other switch. Okay, it works as advertised. What I'm going to do now is I'm going to shut off circuit breaker 10. I'm going to connect the ground wire, and then I'm going to try to screw this in. So I think someone could learn what all the meaning of the ground wires and all are. The problem is historically, you have the electrical engineers, you have the electricians, and then you have the physicists, and they're different conventions. I mean, even one basic is electricity in terms of electrons flows from negative to positive. But the convention that, let me just make sure this is not hot. The convention in electrical engineering, because of Ben Franklin, is current flows from positive to negative. And that's been the convention in electrical engineering ever since. So and then the electricians have this thing with grounding and hot wires, and they have their own terminology. And you're trying to uncoil all that, you have to kind of unlearn things. I mean, you think about it, in some of the Navy teaches for some of the, the stuff on ships, they teach electricity goes from negative to positive, which in terms of physics is actually accurate. You get the electrons moving negative to positive. But in electrical engineering convention, it's positive to negative. And then the electricians have a different set of things. Since these are AC circuits, they talk about one wire that actually carries electricity. And I actually need to learn those terms. And then there's a thing with ground, and then there's polarized outlets. So I don't know what it means when it's polarized. And these are all safety features. And I did one time when I was hooking up a computer network, I grabbed the two coaxial cables that I was about to join. I got electrocuted. This is when I was working as a co-op student in the Internal Revenue Service. And I called the maintenance facility. I said, I shouldn't be electrocuted when I'm joining coax cables. I think you have a ground fault. Sure enough, it was wired wrong. They had a ground fault. So it may have been that they didn't get the ground wires connected. So the grounding on your electrical outlet, I think, is really important when you're connecting devices together. Even something as simple as connecting like your routers or whatever, or coax cables. It used to be that internet was done with coax cables, not like they do now with the E6 or E5, small cables, low power. But those coax cables oh my goodness, I got electrocuted. I called it in maintenance, the IRS building facilities. I said, I think there was a problem. And sure enough, there was. They didn't have the outlet wired right. The computer's plugged into it. If I connected those two coax wires together, we've probably seen a big arc. It was terrible. So there, I don't quite understand the theory of how the grounding is a safety element. And they use electrician language, not physics language. And then it's, again, a little bit different than the electrical engineering language. So see, I wired this wrong. This is counterclockwise. I need to orient it to be clockwise. Hang on, that might be easily remedied. And I really don't like the fact this copper wire here is bare all the way. There's no insulation. But I guess, you know, it doesn't, it's probably a situation where it doesn't matter. And I hope this does connect to something. There's a little hitch here that I need to get through. Okay. You know, I don't like using too much force on these things because they can break. I mean, you know, certainly I could use all the force I need to rip things apart, but, you know, I don't want to compromise. I don't want to compromise the structure. So now I just push this all in. And there are these little screws here. Okay. No, I think I can leave them in. All right, let's push. Okay, I could turn on, I have an extra light here. All right. Now I had a problem with this hole right here. It was so tight that the screw got damaged as I was removing it. I actually had to use pliers to remove the screw. And this is in a lot better shape. Okay. Where did I put my Phillips tip? Let's try this. Yeah, the flathead gets a lot more traction. Maybe I'll try this one. It's a little too big, too small. I can actually feel it. It has more play than I would feel comfortable with. See, I don't like having to use this much force because the thing is, the screw head is so small, it's easily damaged. And I shouldn't have to be twisting this hard either. It's kind of disconcerting. Anyway. I'm damaging the screw as I'm trying to turn this. I don't like that. I don't mind using the force, except it's damaging the fixture. And it's damaging the screw. It's going to be hard to remove. They need to make the screw head a little higher, because there's hardly any way I can get any traction on this thing. I'm sorry to complain, but this is not really well constructed. Okay, almost there. Okay, let me just put a trial plate. I'm going to put this wall plate, this one here. This is the old one. And please tell me that it fits. Okay, so this is going to be the new wall plate. I'm going to repaint all this. Now let me turn on the electrical switch, the circuit breaker. I'll be right back. Okay, the light is working. Yay. So I'll just pull the plate off, and I don't see any sparks. All right. So this stream's been going for an hour 46 minutes, and that's a lot of work just to replace a switch. A lot of work to replace a three-way switch. Okay, I'm just going to finish up here with, I'm going to put some plaster up here. I put plaster here. Okay, let's see this. Yeah, see, you can't, there was a hole that went all the way up to here, up here, and now it's going to be smooth. So again, that's just aesthetics. Here. I need to get this down a little bit. Okay, it's live wire here, but I'm not really touching the wires, I'm touching the fixture. I hate that I'm having to put so much force in there. It's like there's something wrong with the there's something wrong with the hole there or something. I mean, I shouldn't have to be like forcing all my weight on this to turn a screw. I think the box is, there's something wrong with the screw hole. I shouldn't have to put that much force. Okay, let me see if this. Okay, that's a little better. I'll deal with it later. I think I could, a few more turns. Well, that screw's not going to be good again, but hopefully it never has to be replaced. Okay, that's a nice snug fit. Very nice, very nice. Okay, so now I'm going to work on the plaster here, and this should only take like less than 10 minutes. Actually, I have to put on my mask because there's going to be a lot of dust. So there is this stuff called easy sand. It's called quickset. Easy sand joint compound. And I mix it with water, and I'll apply it here. It takes about 24 hours to set, and then I can sand it down. So it's about 1 part water to 3 parts quickset. I just put a little water. It's only about that much water. That's actually more than I need. But, yeah, I emptied about even more of it. And so I have a tablespoon of this quickset. I'm going to put it in here, and I'm going to mix it with the screwdriver. I gotta admit, I've seen pictures of people snorting cocaine. This looks like cocaine. It's like confectioner sugar. When I was a little boy, I saw the construction workers mixing this stuff. I said, that looks delicious. So I have more of this quickset here. The reason I'm wearing a mask is even just getting all the powder. It is so fine, it just, all these particles float. And I was told, the dust can accumulate in your lungs. It's good to wear masks to help protect your lungs. Man, I'm having to add a lot more of this stuff than I thought I'd need to. This is way more than I need. It's getting to be about the right consistency, the right viscosity. I tend to like my plaster on the on the watery side. This is kind of, a professional would kind of cringe that it's dripping. So I'm going to just add a little more, maybe half a teaspoon, and we'll see the consistency change. So I didn't expect to have to remediate another nail pop. Let's look at the consistency now. Not quite so drippy. Maybe just a pinch more. Just a pinch more. Now there are a variety, I'm just using a plastic cups. There are a variety of containers and even pallets that are used by the professionals because they have to do this quickly and they do it in large quantities when they're actually doing installation of an entire wall or room or house. Plastic cup, disposable. I just dispose of it when I'm done. I don't have to clean it up. And I have some sort, this is not a very sharp blade, but it's used for plastering. And, oh, thank you. Well, thanks for visiting, Schnoil. I'm just about to apply plaster. If you have a minute, you'll see me apply plaster. It's very easy. I just slap it on there like that. And then after it dries, I'll sand it. So thanks for joining, Schnoil. God bless you. So I usually put way more than I need because after it dries, it ends up, there are all these little holes and cracks that if you have enough, it's just easy to sand it because this sands like powder. It's so nice. And so even though this is excessive, my experience has been just put way more than you need and then just sand it down. So bye, Schnoil. And with that, actually, I just have to clean up my tools. So I'm just going to shut the stream down. I'm going to play some closing credit music. And let me just move the camera a little bit. I'd like to thank everyone for joining. It's taken me almost 2 hours to change a light switch and hammer a nail pop and put plaster. It gave me a chance to muse about electrical engineering versus being an electrician, and then the conventions in physics of how we describe things. And anyway, so I'm going to switch to my office shortly. Hang on, and we'll shut down in So I hope you've enjoyed another riveting episode of Evidence Reasons Academy. Oh, so Schnoil shared about grounding wires. Thank you. And so he says, in electronics, you also should have a ground wire as touching electronics can kill it. So the ground wire is for protection of the device. Also, there are electromagnetic induction and stuff like this, and within skyscrapers, there could be a buildup of voltage difference, which is equalized by connecting all the ground wires. Thank you. The ground wire is a safety feature. If you have a short circuit between one wire and the casing, then it could shock you. with the ground wire, it goes through there. Okay. Thank you. All right, so I'm going to shut down. Yes, thank you. All right, so I'll just shut the stream down with some music. Thank you all for joining. Glory and honor to our Lord and Savior Jesus Christ. Amen.
Never can feel at ease when I meet him. Never say what I please when I meet him. Only become unbearably dumb and cold. Never can press my suit when I'm with her. Timorous, shy, and mute when I'm with her. I am an inarticulate, bashful boy. If my heart could only find a voice. Ah, me, if my heart could only find a voice.